Hello and welcome to another one of these A-to-D videos. Today we're going to be looking at the concept of enthalpy. If a reaction is carried out in a constant volume container, usually sealed, then the heat transferred or exchange is referred to as enthalpy. If we do this at standard state, meaning 25 degrees Celsius or 298 degrees Kelvin, 1 bar of atmospheric pressure, and at 1 molar concentrations of everybody, then enthalpy turns into this enthalpy with this little degree symbol at the end of it. And that stands for standard state enthalpy. So, chemical bonds must overcome the repulsive force of the electrons on the periphery and the protons in the nucleus. And once they overcome these repulsive forces, they can form a bond, decrease the potential energy, and give off a little kinetic energy. And a third party can come by and pick it up. By a third party, I mean another atom. So you decrease the potential energy of the two forming the bond, give off a little kinetic energy to another atom, thereby increasing its kinetic energy. And since temperature is a measure of average kinetic energy, you also increase the temperature. So, you might be asked to calculate the change in the enthalpies. And the way you would do that is final minus initial anytime you see change, delta. And the final is going to be products minus reactants. You might be asked to do it for these steps or for the entire mechanism, reaction. So C solid plus O2 to give you carbon monoxide, then the subsequent step of forming carbon dioxide. Together the delta H is negative 393. Okay? But there are two steps to this reaction that have their own delta H's. Alright? In this case, we don't have to take the reverse or multiply by any coefficients, but some of these you will have to get the total reaction to net out to be your desired product. But let's say you wanted to, just see the formation of carbon monoxide here. Well, what you would do is you would get the total enthalpy of the formation of these guys here. And if they're in their natural state, they exist spontaneously like that, so their enthalpy would be 0. Formation of the bond requires no energy. And to break a bond, we need to absorb some energy, and then what happens is you increase the potential energy to a point at which the bond breaks, and then the two elements have higher kinetic energy at that point. Once they're broken apart, they use that potential energy as a kinetic. Remember, energy can never be created or destroyed, the first law of thermodynamics. So you could do the net sum here and then the net sum here, forming this carbon monoxide bond, and then do the final minus initial. The steps would be just as I stated. You're going to find the delta H's of the products, sum them up, delta H's of the reactants, sum them up. If they're in natural state, the H's of formation is going to be 0. Then you find delta H using final minus initial, or products minus reactants. So now that we know delta H, we can classify these reactions a little bit further as exothermic versus endothermic. Some reactions release energy, or heat in this case, and they're exothermic. Whereas if you accept energy, you're endothermic. This is an enthalpy diagram in which you have the enthalpy and you look at the individual steps to get from your reactants to products. Now if the reactants are above the products like this, it's exothermic and delta H will be negative. You're literally going to drop heat off and the change will be a decrease. Whereas if it's vice versa, if their reactants are above, then you need to add heat into it to get up there, so it's an endothermic and delta H is greater than 0. So I hope I've clarified enough of the enthalpy basics for you to at least try the problems. If you check out the example videos, you will see that they're not too bad. It just seems overwhelming at first because it's new material, but once you do it, you'll see it's not too bad at all. Practice, practice, practice. Thank you and have a nice day.